All right, so 8.4 proportionality theorems today. So we're going to look at 4 different theorems today, and they're just going to branch off of, we did the other day, we did ratios and proportions, okay? And that's what we're trying to set up, a proportion where it's 2 ratios that are equal to each other, okay? So a ratio is just like a single fraction. So in our example here, RT over TQ would be a single ratio. A proportion is where you have 2 ratios that are equal to each other set up. All right, so we're going to set it up proportion, and then we'll solve for cross multiply and solve for x like we did the other day. So when we look at this, does anybody remember what these 2 arrows tell me? Good. It means they're parallel. What are parallel lines? They never intersect, right? They go their same direction, run the same way. What's our real life example always give? The railroad tracks, right? Okay. You could do the walls, like the walls in a room or something like that, the opposite walls. Okay. So parallel lines never intersect. So what we want to do on this, if these 2 lines are parallel, what it's saying is that these other ones can make a proportion. And what you do is you pick the letter of the triangle that is not connected to those 2 parallel lines. Which letter on that triangle is not connected with the parallel lines? R. Circle it. Because what we're going to do now is we're going to draw arrows from that R going down the side of the triangle that way and that way, so that I can set up a proportion. So if you look, right here, that proportion they gave me, RT over TQ, what they did is they started at R and they did RT, this one right here, over TQ. All right, and they made a ratio with it. Then the next one, they did the other side. They went RU over US. Okay? You have to go the same direction. Start at the same point and go the same direction on these. If not, you can possibly mess it up. All right? So let's do an example. Example 1, and this is, I put on there for today, it's really nice. Every single one that you're doing today on the worksheet, like, you'll be able to see which example to look at. Okay? So this one's like number 1 and 2 on practice A, and like number 1 on practice B. So we need to find the length of AB. So I'm going to put an X where AB is, because that's the one we're looking for. We don't know what it is right now. What letter should I start with on this one? A. Why should I start with A? Yeah, I think I heard y'all say it. It's like it's not connected to the parallel lines, right? Okay. So we're going to start with point A. And then we're going to draw arrows going down each side, so that I can see where do I start and what direction am I going on each side. Okay. Take that couple seconds just to do that on each one, and it'll help keep you from messing up. So now I'm going to start at A, and I'm going to go down that left side, and I'm going to name the sides. So that first little side here is just A to E, point A to point E. So I'm going to say AE, over, and then I keep going. The next one is ED. So Jordan, name so going down the right side, what's that top one going to be? What's the name of it? What's the name of this top one right here? Like, when I go down this way, what's... No, the first one. Starting here is going to be... What's this first section? AB over... Not AC, but the next little one? BC. There you go. So AB over BC. Okay. So I'm just writing out the names of each one. Now I simply just plug in what does each of those little lengths equal. So when I look at AE, it's what, class? 14. Okay. So we just simply looked at AE and we just said, oh, it's 14. Then Aubrey ED is what? 12. All right, let's do the other side. Fable AB is how much? X. Damien, BC? 18. All right, now we got a nice proportion set up. So now we can just simply cross multiply and solve for it. So this is now like that worksheet we did the other day. So I'm going to cross multiply. Do 14 times 18 equals 12 times x, or just 12x. What's 14 times 18, anybody? 252. 252 equals 12x. And then we divide by 12. And I heard somebody said x equals 21. Okay. And what side did that represent?
A to B.
AB, right? So we want to say, because that's what we're looking for. It's 21. I mean, it's AB. So we want to put AB equals 21. We just put x there just to represent it. But we actually want to put AB equals 21. All right, when you do your worksheet, make sure you take note which length they're actually looking for. I'll give you a hint. Number 2 on practice A, there's one of those little sides is missing, but they're actually looking for, I think, AB. So you have to find that little missing side, and then you have to add them together. Okay, so keep that in mind. All right, theorem 8.7, converse of the triangle proportionality theorem. Remember, converse is just almost like the other way of looking at it. So the other theorem said that they told me the two lines were parallel, and then so we could set up a proportion. This one is saying, hey, tell me if the two lines are parallel. So we set up a proportion and just see, do they actually equal each other? Okay. To me, this one's actually a little simpler. So let's solve it. It works the same way, basically. Which letter should I start with on this one to see if KM and JN are parallel? L, because L is the one that's not connected to the ones we're trying to test if they're parallel. So these, we're going to go up. So on that left side, when we work our way up, we'll say LK over KJ. And Landon, what's the other side going to be?
Oh, my bad. LM over MN.
LM over MN. Okay. So we just worked up the left side from the L, worked up the right side from the L. Okay. Ethan, tell me what to plug in on that left side. What's that left ratio? 25 over 22.5. Okay. Adriana, what's the other side, the LM over MN? 20 over 18. Okay. Do we have an x to solve for on this one? No. All we need to do is see, do these actually equal each other? Okay. There's different ways you could do it. You could do like cross multiply and see if they equal each other. The way I typically teach it is I just reduce the fractions. Okay. So both of these fractions, if you reduce those and they come out the same, yes, they are parallel. If they come out different, then they are not parallel. So how do we reduce fractions with the calculator? Like what do we do? We divide it. So the first one, 25 divided by 22.5. Then what do we hit? Math enter, right? So do that on each side. 25 divided by 22.5, math enter. 20, and then the other one, 20 divided by 18, math enter. All right, so Caden, the left one, what do you get? Do 25 divided by 22.5, math enter. 10 over 9. And Thomas, for the 20 over 18, what does that reduce to? 10 over 9. Are those the exact same, class? Yes. Are these parallel? Yes. So you're just going to write yes. On your worksheet, I don't think it wants you to explain, but we're just going to explain it here just so that when you look back, you know why. Yes. They are parallel because they equal.
And we have to put a fraction.
What?
We have to put a fraction.
No, it's just, they just want to know like yes or no, are they parallel? So on your worksheet, like I say, it doesn't ask to explain. You can literally just tell me yes or no. So this is the three parallel lines theorem. Okay. This one I think sometimes it's easier, it's not as easy to just like notice as quickly as the triangles, but it works the same way. So if you look at this, we have UW over WY. UW, this little section here, over WY. So what they did is they ran left to right. So whatever I do on that top one, I have to do on the bottom one too. So I'm going to run left to right there. And then you see it's VX over XZ. And if you notice, the top of these ratios, you see how they're in the corresponding parts, or the same part on that each line? Like the top was on this left side of this line, this VX was on the left side of that line, right? Okay. So that's what we're doing here with a proportion, is we're setting up the ones that correspond with each other. They're on the same part of each one, okay? And we can use this principle, what we'll end up using it for is with similar polygons, okay? Polygons that we can find missing sides if we know like the corresponding sides on another polygon, okay? But so like we ran this way, UW over WY, VX over XZ. Let's do this example. Ain't talk. It's like 5, 6, and 9 on A, and number 2 on B. So once again, I'm just going to run left to right. And whatever way I go on one side, I have to do on the other. So I'm going to set up the proportion. The top is PR over RT. So Giovanni said NS over SU. So let's plug it in. Jacob, the left side, PR over RT, what's the numbers I plug in for that one? 8 over 12. And Cinnamonson, what's the right side going to be? Oh, and I forgot, we look for XU. We need to put X there. Not X over 10 because we're going left to right, so it's going to be, there you go, 10 over X. And if you're ever confused, guys, once you get it, remember you just plug it in like NS. It's right here, so it's 10. Just plug in for each one. All right, cross multiply, solve for it. 8 times X is 8X. 10 times 12 is 120. Then we know we're going to divide the 8. 15. So X equals 15. And it was looking for SU. So SU is equal to 15. What if it was looking for NU? What would we do?
Add that to the part.
Yeah, if it was looking for N to U, we'd have to find this one. And then once we found this one, we would add it together just to get the total length. All right, to me, this one's the one you really gotta use a little more of your brain power for this one. Okay? It's not always quite as obvious. Now, I do want to say that with proportions, you can set them up different ways and still get the same answer. Okay? I'm showing you one way of doing it. But if you're setting up the same part with the same part on each one, there's different ways of doing this, okay, and still coming up with the same answer. I'm just showing you the way that, in my mind, is the easiest way to do it. Okay? So if you come up with an easier way, and if you want to show me, I can tell you if it's a good way to do it or not. Okay? But if it works for you. All right, so this one, what they said is AD right here over DB. Oh, before I do that, what's the bisector do? Cuts it in half, right? Okay. So I need to cut it in half. Is it cutting the triangle in half, or is it cutting an angle in half? Angle. Okay. It doesn't say triangle bisector. Okay? People get messed up with that because they see, oh, triangle angle bisector, so they think this line is cutting this whole triangle in half. And then they think, oh, AD and DB must be the same. But that's not the case. It's cutting this angle right here in half. So that makes it congruent on each side of these right there for the angle. It does not make this line congruent on each side. All right, so don't get that confused. And so what you do is you combine like these two right here, the one that share the same side, okay, AD over DB, and then you would take like this one and this one, CA over CB. Let's work an example to try to clarify that. So this is like 7, 8 on A and 3 and 4 on B. And they want us to find line P, or find P. Okay. So once again, I want to put together the ones that are on a whole side of a triangle. So if I was to highlight this triangle's edges, that's the outside edges of a triangle. Do you see how 16.5 and P, like they make up a whole side by themselves? Okay. So those two I want to put together, the two that make up the whole side. But then I want to put together the two that make up that split side. Okay. And same thing, you got to go one direction. All right, so either right to left or left to right. I just commonly go left to right. So I know with the purple there, the two sides, that's going to be 16.5 over what? P. Okay. Now, before I do the other one, do y'all think it's going to be 11 over 29? No. Why is 29 not going to be the one?
Because you gotta take 11.
Okay. So good. 29 is the total. It's the whole side, right? We don't want the whole side. We want this little part over this little part of the side. So as River said, the whole thing is 29. So I can subtract out that 11 and get 18. And that's my missing one right there. Okay. Does that make sense? So what is this? So what's this right side going to be? What over what then, class? 11 over 18. Now we got it set up, and we just cross multiply. Gabby, what do you get for 18 times 16.5? $297 equals 11p. We solve for the p, so we're going to divide by 11. $27? $27. And it didn't ask for a side, it just asked for p, so I'm just going to leave it p equals 27. And that's it.